optimal minimal.
At this altitude, I can run flat out for a half mile before my hands start shaking.
Can I ask you a personal question?
Now would seem an appropriate time.
What if I did the opposite?
I'm a cybernetic organism, living tissue over a metal endoskeleton.
This episode is brought to you by AG1, the daily foundational nutritional supplement that supports whole body health. I do get asked a lot what I would take if I could only take one supplement. And the true answer is invariably AG1. It simply covers a ton of bases. I usually drink it in the mornings and frequently take their travel packs with me on the road. So what is AG1? AG1 is a science-driven formulation of vitamins, probiotics, and whole food sourced nutrients. In a single scoop, AG1 gives you support for the brain, gut, and immune system. So take ownership of your health and try AG1 today. You will get a free 1-year supply of vitamin D and 5 free AG1 travel packs with your first subscription purchase. So learn more, check it out. Go to drinkag1.com/Tim. That's drinkag1, the number 1, drinkag1.com/Tim. Last time, drinkag1.com/Tim. Check it out. Hello, my little mogwai. This is Tim Ferriss, and welcome to another episode of The Tim Ferriss Show, where each episode is my job to deconstruct a world-class performer, take a peek under the hood, inside their brain, tease out the thinking, the frameworks, the tools, tricks you can use. In this episode, we have, well, first of all, waves in the background, waves lapping at the deck next to me, and I have had a change of location to a more beach-based environment. But we also have Professor Lisa Randall. I'm so excited about this one. She is at Lyra Randall on Twitter, L-I-R-A Randall, who researches particle physics and cosmology at Harvard, where she is a professor of theoretical physics. Professor Randall was the first tenured woman in the Princeton physics department, and then the first tenured female theoretical physicist at Harvard. She is a killer in the best way possible. In autumn 2004, she was the most cited theoretical physicist of the previous 5 years. 2007, Randall was named one of Time magazine's 100 most influential people under the section for scientists and thinkers. Randall was given this honor for her work regarding the evidence of a higher dimension. And we get into dimensions, we get into time, we get into hidden dimensions and all sorts of fascinating things in this conversation. She's also a very adept rock climber, among many other things, and has a lot of involvement with music. She has written several mind-expanding books, the newest of which is Dark Matter and the Dinosaurs, subtitled The Astounding Interconnectedness of the Universe. And if you want a semi-psychedelic experience, viewing the world through a new lens without imbibing any substances or risking incarceration, the book is well worth checking out. I love reading about physics. It is a pet obsession of mine. Many of you know I have as one of my heroes Richard Feynman, and we go all over the place. I know not of what I speak when it comes to physics, but I do enjoy speaking with someone like Professor Randall. And I should make a couple of notes. The first is that we had some connection difficulties. So the sound quality may be challenging, and I ask you to bear with me. Please don't bitch and moan excessively on the internet about it, because here's the thing. With very busy guests, sometimes it is a go or no-go decision. That means we can do an interview with suboptimal sound quality, which I think is perfectly fine for most people, quite frankly, or we can not do the interview at all because schedules need to match. So please bear with us. I appreciate your patience. I still think that you'll be able to get a whole hell of a lot out of it. And I think 99+% of it is audible, so you should be able to get tons. And then last but not least, I'll repeat, Professor Randall has a question at the end, and she'd love to hear from you. So please ping her on Twitter at Lyra Randall. So name Lisa Randall, but on Twitter it's Lyra Randall at LIRARANDALL. And with that, please enjoy my conversation with Professor Lisa Randall. Professor Randall, welcome to the show.
Thanks for having me here.
I am so excited to dig in today and to talk for many, many reasons. We have mutual friends, of course, but beyond that, I have been simultaneously fascinated by physics and embarrassed by my lack of knowledge of physics for a very long time. I went to Princeton undergrad, became obsessed with Richard Feynman, bought Surely You Must Be Joking, Mr. Feynman, and then his many other books. And I'm hoping that we can dig into your areas of expertise, but also perhaps just answer some very basic questions that have led me to have a lot of insecurity related to the sciences. So that's a long intro, but I'm happy to have you here. And
Can I just chime in?
Yeah.
It's really funny because one of the very funny things about talking to people about physics, I actually mentioned this in the end of my book, is it's really funny because whenever you tell people you do physics, everyone feels compelled to tell you their attitude or relationship to physics in a way that they don't. For example, if you say I'm a lawyer, they don't feel like they have to tell you how they feel about the law. But somehow with physics, everyone feels like they have to tell you whether they like it or they hate it or they're interested or not. It's very funny.
well, I feel like pleading ignorance up front is always good insurance policy. So if I'm wading kind of deep into the,
I see. It's plausible deniability.
Yeah, plausible deniability. If there's a likelihood I'll drown in my own stupidity later, then I want to put on the life vest of plausible deniability first. But when you're at a cocktail party or any type of engagement, when you meet someone and they ask you, what do you do? How do you answer that question?
Obviously I'm going to tell them in most circumstances that I'm a professor of physics, and what I study. That I study the fundamental nature of matter. I study the universe, how the universe has evolved, the nature of space. But I don't necessarily go into all of that. Sometimes, if I want to make my life a little bit easier, I'll just tell them that I write about physics. And then eventually they'll ask me what I write about, and then it will come back to the fact that I'm doing research too. But it's really interesting because one of the things for me when I started writing about physics, in addition obviously to doing research, which is really the primary thing, was I found that it's so much easier to talk to people about it because people understand writing more than they understand research.
Or they think they do, at the very least.
That's a good point. It turned out, though, that I had many more friends who were writers than I had appreciated. Like, once I started writing, I realized, oh, wow, I have a lot of friends who write.
All of these closet authors come out of the woodwork.
No, they were actual authors. It's just I'd never actually made the list and realized what a good, sizable fraction of my friends were writers.
Now, I'm looking at your bio, and I've spent a lot of time looking at your bio, and I have to admit that I could really use some definitions. So you research particle physics and cosmology at Harvard, where you're a professor of theoretical physics. So I'd like to start with the basics. Physics. Like, what is or what are physics?
Of course, that's a question that changes at some level with time, but really we're trying to understand the fundamental nature of matter, what stuff is made of, and how it works. Sort of the physical processes by which things happen. I mean, there's other levels at which we can look at things. We can look at them biologically. We can look at biological processes, or we can look at psychological processes. But ultimately, we're looking at the substrate. We're looking at the matter from which all these other things emerge. What is stuff made of? And how do we put it together to get the kinds of things that we observe? And what are the forces that act on that matter to produce what we see?
So these are questions that people have had for a very, very long time. What is theoretical physics, and what is the alternative?
Theoretical physics means that I can do my work with essentially a pencil and paper. I'm not running the experiments with which we'll test the ideas, and I'm not running the experiments that provide data. I might interact with experimenters and do quite often and say this would be an interesting thing to look at. I look at the data. So it's not that I don't care about what happens with experiments or observations in the case of astronomy, but I am not doing those things myself. Mm-hmm. I'm thinking about how we can tie it all together in a theoretical sense. How do we make sense of what it is that we see? What are the fundamental underlying connections? What are the forces? What is there? It's actually producing all of this.
What is cosmology, and what is, I'm stumbling over whether physics is a plural or a singular. I guess people just say is particle physics.
Yeah, physics is a word like chemistry. It's I guess a singular the same way chemistry is singular.
Got it.
But what cosmology is the study of the evolution of the universe, how the universe has become what it is today, how it's changing. The universe as a whole, how does the universe evolve? What particle physics is a study of what is the fundamental nature of matter? If you keep digging deeper and deeper, what is the basic stuff of which things are made, and what are the forces that act at that level?
Mm-hmm. And when we talk of, and don't worry, I'm not going to.
So just to clarify, I'm just going to go back a step on that, since it didn't seem that was completely satisfactory. So, like, if we're talking on a computer, it's made up of stuff. It's, everyone knows it's made up of molecules, which are made up of atoms. Those atoms are made up of nuclei with electrons around them. The nuclei are made up of protons and neutrons, which are made up in turn of quarks, particles called quarks, which are held together by gluons. So as a particle physicist, I'll study things at the level of quarks and gluons and electrons and the photon that produces electromagnetism. And I'll say, is there an understanding of why those are the particles, why they have the masses they do? Are they fundamental? Are there even smaller, in some sense, particles of which these guys are made? So we're trying to understand what are the basic elements of matter and how they're related.
Got it. Thank you. And I've so many questions, but I want to turn back the clock a little bit because there's the current state.
Don't we all?
I know. It just so happens, and I didn't time it purposefully this day, but today is Back to the Future Day. And apparently I look,
That's right.
which is perfect.
That's right.
Very appropriate. And it turns out that, a lot of my fans think I look exactly like Biff Jr., who wears a chrome helmet, so people can look that up. But I had a lot more hair. So yeah, turning back the clock is always something I've wanted to be able to do. But if we look at, and please feel free to correct any of this, you were the first tenured woman in the Princeton physics department and the first tenured female theoretical physicist at Harvard. Your sister, I believe, is in computer science. Is that right?
Yeah, she does computer science theory. Mm-hmm.
Okay.
Mathematician.
So you're both women in male-dominated fields. How did you both end up as scientists? What was the formation of both of you, or speaking to your personal experience as scientists?
Well, there's sort of a joke. I mean, my sister, who's 4.5 years younger, gets mad at me because people will ask me, were there scientists in my family? And I'll say no, because, when you're a kid and your younger sister is 4.5 years younger, you don't really feel like there's another scientist in the family. And we weren't scientists back then. So, but when they ask her, she will say, yes, my older sister did science. But having said that, I mean, she's absolutely brilliant. And of course, she's, outstanding scientist today. But, it's hard to say exactly what it is. I mean, when people ask me, I always joke, only half jokingly, that I wasn't properly socialized. I just didn't know that I wasn't supposed to do it. And, we were both good at it. And, and I like challenges. I thought if this is something I might want to do, I should try to do it and see how it works out. But, it's funny because people are much more open about talking about this as an issue. It's not like I didn't notice that I was the only woman in my class, or actually sometimes it was even worse than that. There would be a few women in the class, and by the end of it, I'd be the only one. And, it's not like you don't notice that. But, it's not a defining feature. I mean, I was taking the same classes. I was studying the same things. It wasn't something. So, it's something actually, sort of as you get more senior, you're more aware of it in the context of how it affects your relationship with colleagues. But at the time, I was just trying to do my work, really.
If we look at some of the specifics, for instance, again, I'm just pulling from the Cliff Notes here, but did the Hampshire College Summer Studies in Mathematics come before high school, or was that during high school?
Actually, it's really interesting that you ask about that. I'm really happy you brought that up. I actually did that when I was in high school. And, it was at Hampshire College, and so it was actually a fun place to be. It was Western Mass. But it was, essentially math camp, and it sounds totally embarrassing. But for us maladjusted people, it was actually a really fun thing to do, to get out of New York City and to go there. But joking aside, I actually feel very strongly that these summer programs are really important. I was at one NSF meeting, National Science Foundation meeting, where they were asking about things we can do, and I actually raised the fact that I thought having these summer science or math programs can be really important. And it was really interesting to me because I think, the other women in the room felt the same way. And I also think it's something that actually helps with minorities, helps with disadvantaged students. because it's a way to get outside whatever is your environment. I mean, I'd love to believe that we can just, instantly improve all high schools all over the country, but we're not going to do that right away. And so the idea that the best students or the best students in a particular area or students with a lot of interest in an area have the opportunity to meet other excellent students and have fun with it and see, and not be defined by their environment. I mean, this is it was Hampshire College. I mean, people came from all over. And I actually think that's a very valuable experience.
I agree. Yeah, the translation of location and that social circle, or there's just the context that may be hindering or helping, depending on the person, I've also found really valuable. So I did, I hesitate to say this because it implies I actually know something about it, but I actually went to a summer camp for physics at Northfield Mount Herman in high school, and then went to
awesome. That is so great.
Now, in fairness, it wasn't because I was excelling and trying to graduate in 3 years. It's because I wasn't going to graduate if I didn't satisfy my physics.
But even so, it's really nice. I mean, I was talking to someone. I mean, one of the problems or good things or bad things, I don't know how you want to view it, but it's to find a feature of the educational system is that if you don't do the subject at the same rate, you're going to be in trouble. And it's something that in the sciences and in math is a much more serious issue, I think. If you fall behind in a physics class or in a math class, you're basically never going to catch up, and the rest of the time is wasted. So to have these opportunities to sort of catch up, I mean, I think is very important.
Oh, I totally agree. And, it's just, this is maybe, I wasn't planning on bringing this up, but it's an interesting example of early influences. And I'm not going to let go of the story of you and your sister. We're going to come back to that. But in 10th grade, my younger brother and I went to the same school. And in 10th grade, we both had two different math teachers. And my math teacher was actually, really, she was a good teacher, but she was very kind of embittered through the academic process. And I ended up disliking math as a result. So I actually went to Princeton partially because there was no math requirement. But that led to the necessity of going to physics summer camp. So it kind of blew up in my face in that respect. But
that's an awfully interesting way to choose which college you go to.
Yeah. Well, it was a necessary but not sufficient, criterion. But my brother, on the other hand, had a wonderful experience in 10th grade, same year. Neither of us were predisposed to math, and he's now, he has a PhD in statistics, or he's finishing his PhD in statistics.
So interesting.
So for you and your sister, if you look back, I mean, what did your parents do when you were growing up in Queens? I believe it was, right?
Yeah. So just for the record, I actually have two sisters.
Okay.
I have an older sister who actually was learning disabled in some level, and she was my older sister. So just to be clear,
of course.
And I think it's one of the reasons I was very aware of, just how you learn and valued education a lot. I did feel level that I was lucky, that I was able to learn things, and so I felt sort of a responsibility to really learn because of that. I thought, I was given this ability, and I didn't want. I just thought it wasn't really fair, and I thought I should be able to use it. I think part of it, was frankly, just taking it seriously, at least our studies. It's not that it was all easy, and I actually had to argue quite a bit to go to Stuyvesant High School because it meant I had to take public transportation in the 70s to get to high school from Queens to Manhattan. But I think there was a sense in which, they did just value learning. And so
your parents,
I think so. And I think,
what did they do professionally?
My mother was a teacher, and she stopped when she had kids. And my father, he studied engineering, but he did sales representative, really. So they weren't scientists by any means. And a lot of people ask me, my parents were scientists, and they weren't. I mean, it really was something that I really decided for myself. It was something I was interested in and wanted to do. I mean, I think both my sister and I, we really liked math. I mean, I also grew up, went to school, started school in the 60s. I shouldn't give away my age, but it's easier to look up on Wikipedia anyway. But and it was this time of great uncertainty. I mean, my joke is my first day of school didn't exist. We had school strikes and all of that. And I think I liked, the sort of certainty of sort of math and science and having answers.
Right.
Of course, when you do research, you realize it's all about not having answers. But there was, but no matter how bad the teachers were, there still was going to be like a right and wrong answer of everything. And, you could still learn it on your own if you needed to. And I think that was probably one of the things that, I mean, it's not, I liked reading. I liked all sorts of things. But I think I did like that sort of sense of security that you have with numbers and, or with math. And it was fun. It was fun to play with it. I like puzzle solving. I think my younger sister does too. And so I think, like I said, I mean, she was a lot younger, so I really felt like I was sort of deciding these things, but it's not like I knew right away. I mean, I remember in junior high school very decidedly thinking I would be a lawyer.
Why a
lawyer? It's not like I knew anyone.
Why a lawyer?
I think I had a very idealistic sense of, finding the truth and arguing for the truth. And I wanted, I don't know, I like getting the right outcome. So it seemed like something that would be worthwhile. I think it was before the days of junior high school students knowing about corporate law. And then I went to high school. I went to Stuyvesant in New York, and I just also want to say how important I think really good public schools are. I mean, it was a public school that I got to by public transportation, which honestly was a pain, but I got there. I had to take a bus to the subway. But there was a way of getting there, and I just I took my first physics course and liked it, and I couldn't really see myself necessarily doing math for my entire life, but I thought it would be interesting to try to understand the world, through math. And, there was never an option for me to be an experimenter. I always was going to be a theoretical physicist if I did physics.
Why is that?
It was, I just liked the sort of game playing. I liked the sort of solving problems. And I have no patience, and I'm very messy. So I would make a terrible experimenter.
Oh, that's funny. It kind of reminds me of a question that I was asked when I was researching cooking for the 4-Hour Chef, and they said, "Do you like to fold your socks or your underwear?" And I said, "Kind of." Why? And they said, "Because that would mean you're going to be good as a baker. If you're going to be a chef, those are like the messy folks who are impatient."
That's very funny. That's very funny.
The conversation with your parents to go to high school and take public transportation. Tell me about that. How did that go? What was your argument?
Well, I actually did I took the test, and I mean, it sounds like I'm bragging, but I mean, I'm answering your question. I really did one of the best of the tests in the city. And I felt like I kind of had a right to go, and I just really wanted, the schools in my neighborhood were okay, but, there were actually issues coming up, and there were actually racial issues in the neighborhood, and, high school was kind of a mess nearby at the time. I mean, it wasn't terrible. People did fine, but, I really wanted to go to a good school. And frankly, what I really wanted was to get out of Queens too. I found I wasn't that happy there. I found it was like everyone was supposed to be the same, and, and I was right about that. When I went to Manhattan, people had, could be individuals. It was valued, and I really loved that. So just, it was sort of the social experience as much as anything that I really liked being able to get into Manhattan every day. But there were ridiculous deals I had to make. I was actually the first woman captain of the math team, but math team met at 8:00 in the morning. So that meant leaving really early. But my mother didn't want me to go out in the dark. And, in the 70s, there were lots of bad things happening in New York. But, the fact is I had to get to school. So there were compromises to be made, but I got there. And then by the time I also didn't go until 10th grade, but by the time my sister went, I'd already paved the way. And so she actually started, I believe, in 9th grade. So she was a little younger when she started.
You had given your parents the dress rehearsal, or not the dress rehearsal, but the sort of debutante ball with all of the fears and concerns.
Never thought it was a debutante ball, but that's very lovely.
Probably not the best metaphor, but that's okay. So you've written a lot, and I want to look at your I'm not sure if bibliography, I'm looking for the writer's equivalent of a discography, but your books to date, and key in on some of the phrases that are used and will lead up to the current day. So Warped Passages, subtitle Unraveling the Mysteries of the Universe's Hidden Dimensions. Can you explain why the title and subtitle of that book?
I can try. So, it's actually very funny because I originally was going to call my original thought for a title was Extra Dimensions, Are You In or Out? Which sounds kind of fun. But that was nixed. So I had to think of another title, and I thought Warped Passages, and it actually is a joke that really no one gets. So warped comes from the idea. So the science term warp comes from the idea of what happens in the particular geometry with additional dimension of space that I looked at. So the book is framed around ideas about an extra dimension of space beyond the three that we see. And warped refers to the fact that things get scaled differently in a different dimension. That is, so they kind of get resized. So Warped Passages was a little bit of a joke because it was the first book I was writing. So I was sort of making fun of, I was just joking about writing. So it was like Warped Passages. And it was, but it was Warped Passages in the spatial sense. It could have many interpretations. I mean, my friend looked at the title. She's like, "Oh, is that your autobiography?" So it was really like funny. A joke. I kind of liked it.
Does your editor have any idea that was an inside joke?
I don't know, but I know that I was told that the marketing department got hold of it and said, "Can't you just call the book Extra Dimensions?" And I was like, "No." I didn't find that a very interesting title. But I spent a month trying to think of a better title, and then I realized, actually Warped Passages is a great title, and people really liked it. So I was very happy I kept it. But I did think because it was this sort of nondescript title, or at least could be interpreted differently, I had to explain, at least in the subtitle, what it was. And it really is about unraveling mysteries, of the hidden dimensions, both in terms of dimensions of space, but dimensions sort of metaphorically, understanding what's really out there underlying the universe. So, there's a lot of thought did go into that subtitle as well.
And when we talk about hidden dimensions, I'd love to hear you just elaborate on that a little bit, because, for instance, and we're not going to dwell on this, but I'm reading for the first time, and I'm embarrassed it's the first time I'm reading it, but The Time Machine by H.G. Wells. And in the beginning, there's a cocktail conversation, and the time traveler is asking people how many dimensions a cube exists in, and they say 3, and he says, well, actually, it's 4, because can a cube exist for an instant, right? And then we get into this discussion of time and whatnot. But in that only further piqued my curiosity and interest in chatting with you. But when we're talking about hidden dimensions, could you elaborate on what you mean by that?
So when we talk about dimensions, we have to be careful to distinguish dimensions of space and of time. Einstein talked about space and time as expressions, and in some sense, there is a concept of space-time geometry, for example, but space and time are actually different. So when we talk about a fourth dimension, we might mean time, but we can also mean a fourth dimension of space. And when I talk about a fourth dimension of space, you might say, where is it? What is it? And obviously, it's hidden. We see 3 dimensions of space, up, down, forward, backward, left, right, but we don't observe that fourth dimension. And that could be either because it's really tiny and hidden from us. You might think of a wire that looks one-dimensional, even though we know in reality there's more dimensions, but we're not resolving those necessarily. And in the same way, space can have tiny hidden dimensions. But my collaborator, Raman Sundram, and I discovered still another way that an extra dimension could be hidden, and that's because space is so warped. Space-time can be warped. And that's actually what gave rise to the title of the book, Warped Passages. And the idea is that gravity varies so much across an extra dimension of space that its strength is so small, far away from some location, that it looks as if there's only 3 dimensions, even though there can be a fourth, even infinite dimension. It's just that in some sense, gravity doesn't leak out into it. It stays concentrated in 3 dimensions.
Okay. I'm tempted to ask about Interstellar, but I might do that later.
Okay.
Have you seen Interstellar, the movie?
I have, but let's do that later.
well, no. That was not the question. I'll come back to it.
Okay.
So the next book, Knocking on Heaven's Door: How Physics and Scientific Thinking Illuminate the Universe in the Modern World. So both of those were New York Times, New York Times 100 notable books. I'm most interested here in the title. Why Knocking on Heaven's Door?
It's a good question. And as anyone who read my first book knows, I have this mind that I record, sort of remember song lyrics and titles. And so
Guns N' Roses?
Sort of obviously play in the words. Well, it's interesting. You could tell someone's age by whether they say Bob Dylan, Guns N' Roses, or they think about dying, when they see or hear that title. And so it's, what I wanted to express was the way science builds on itself. I know it sounds like not the way of doing it, but the idea is that there's a whole body of knowledge that we have, but we want to get to the edges. We want to say, how can we expand on what we know and go beyond? So that I like the idea of knocking on heaven's door as sort of a way of opening beyond the stuff that we know into the realm of the unknown, but in a way that's so close to what we know, but beyond it and improves upon it. And also, it was a time when science and religion got discussed a lot, so I do actually talk about in this book not just the particular science I do, particle physics and the Large Hadron Collider, but I was also interested in just explaining what science really is. I felt like neither side sort of was giving a completely, a good enough explanation that they could talk to each other. And I think I feel like I did a good job because when I gave it to scientific people, when I gave it to religious people, neither one were completely happy. So I feel like I did a good job. And in fact, I gave it to someone who runs the MIT parish, and he said he read one of my chapters, and he said, "I hate to admit it, but you're making a lot of sense here." And that was what I was looking for. That was the target I was looking for. That compromise.
So what was the in this case, was it a definition of science that provoked that response, or was it?
It was in some sense. I think we have this idea that when we understand the fundamental nature of things, we'll understand everything. And one of the notions that I really focused on in this book, which I think is a really useful notion for people to take away, and I'm not sure I'll be able to do it justice in this brief time, but the idea of an effective theory, the idea that you know what you can see, but you don't necessarily know what underlies that. So let me give you an example. So Newton's laws work very well. They work very well over a definite regime. And unless you get extraordinarily precise, you won't realize that quantum mechanics or relativity are actually more fundamental than Newton's laws. So I'd like to think, I remember when I learned in high school about Newton's laws, I thought, and then they was told that they're not really right. I thought, why are they teaching it to us? Well, they're teaching it because it is right, but it's right in the sense of being an effective theory. That it's right in the regime that we do it. If I want to predict how to throw a ball or even how to send a rocket to the moon, Newton's law is fine. It's just that if I get into the scale of an atom, then I'm going to need to use quantum mechanics. So I like this idea that science builds on itself. It doesn't mean the other theories are wrong, but it means they're effective theories. They work over a certain regime. And the reason it's important related to the other discussion is sometimes people will think, well, this can't be right. We'll never answer certain questions. But that's not true. You still need the fundamental elements of matter. Even if I don't yet understand how the brain works, I know fundamentally there are atoms involved and there are photons communicating electrical forces involved. It doesn't mean I know all the answers yet. And it might be that I'll have to look at it at some higher level to get those answers. But it doesn't mean science can't tackle it, but it's tackling it systematically and through this effective theory idea.
Mm-hmm. And so I've read that your research has at its heart, and I'm quoting here, the search for fundamental connections in the universe. Can you explain what that means?
Well, that's the most recent book where I'm looking for those. Is that what you're referring to?
Yeah.
So,
and I could set that up by saying, a comet struck 66 million years ago that wiped out the dinosaurs and 2/3 of life on the planet. What happened? That was my alternative.
Well, let's first say that the title is Dark Matter and the Dinosaurs, and the subtitle is The Astounding Interconnectedness of the Universe. And it refers to both those things. It refers to the research I'm doing, where we'll get back to, which is dark matter connecting possibly to the extinction of the dinosaurs. But The Astounding Interconnected of the Universe was a little bit about, there's sort of two things I really wanted to get across in this book. obviously my research, but also how the different fields of science relate, how cosmology, the evolution of the universe, the Big Bang Theory, inflation, and dark matter, those ideas can connect onto our solar system, our galaxy, and then our solar system. And our solar system, and how we have an active solar system with comets and meteoroids, and how those could be related to life and life's extinction. So all these amazing continuities, sort of how this all evolved, but also how these basic elements, like how nuclear forces can be relevant for driving plate tectonics, which is relevant to the carbon cycle, which, as you know, is relevant to life. Just these amazing connections that exist in the universe, how heavy elements were formed in supernova. Just all of these different connections between I was very excited because I studied fundamental particles, as I talked about early on, but it's very hard. It's abstract, it's hard to grasp. But then I can make these concrete connections to things that we do experience in our daily lives. And of course, dark matter and the dinosaurs is sort of the ultimate of that sort. That dark matter might ultimately connect to something as fundamental as the extinction of the dinosaurs. Well, fundamental is the wrong word, but it's important to us, which allowed for large mammals to dominate and eventually us. So I think that these connections, and understanding the role all of these play, how dark matter helped form galaxies, all of these things that we think of as so abstract, sort of what are their concrete manifestations? What are they? Was important. And the other sort of even bigger lesson in some sense is, just kind of our history, the planet's history, life's history at some level. And just how long it took to get here, and what are the different things that happened in it, and just the amazing connections that were necessary, the amazing features that were necessary for all of that to happen. And I think it's especially relevant in light of the rapidity with which we're changing the planet today. Since the Industrial Revolution, we've had enormous changes to the planet. And before we do it, I wanted us to understand what that means, sort of understand the context and what are the things that got us here, and what it would mean to maintain it.
So I'm going to ask you about dark matter, and I have some quotes that I really enjoyed related to that. But first, could you explain the relationship with the I guess it's geological tie-in with mountains and what was it? Nuclear decay?
Well, I think most of us now know about plate tectonics, which was actually developed relatively recently. The idea that the plates are moving and over the mantle,
right,
which is liquid. And what drives that, what gives you the heat, is the fact that there's nuclear decays. And nuclear decays are providing the heat that drives this motion. And of course, as you know, plate tectonics has given rise to mountain ranges when things crash together or when they disappear. And volcanoes. And so all of this dynamic stuff that's happening is being fueled by, at least partially, by nuclear decay. So that's kind of an amazing connection. And also the carbon cycle is coming in part from this, the emergence and disappearance of mountains.
Thank you. I became very interested in dark matter and dark energy about, I want to say 6 months ago, when I read an article called A First Glimpse of the Hidden Cosmos, which is written by Timothy Ferris, a different Timothy Ferris with one S.
Right.
Fantastic.
I accidentally emailed him today instead
Oh,
of
my
you.
God. Oh, that's really funny. Okay.
He actually blurred my book. He was very lovely.
He's a great guy. That was in National Geographic. If you could extend to him my sincerest apologies for creating so many issues for him on Google, because everyone misspells my name. So I've just created a huge amount of noise related to his name inadvertently, and I feel terrible about it. I think I live a few miles from him. So in any case, I'd love to take him out for coffee sometime and apologize in person, which I tried to do at the I tried to track him down at this Exploratorium event to apologize in person, but I didn't find him. In any case, there were a couple of quotes in there. So one of them was, and this has some ellipses at the beginning, but the most profound mystery in all of science. That's astrophysicist Michael Turner on dark energy. Empty space is not empty. That's John Archibald Wheeler. And then the article ended with scientists are confronted by the embarrassing fact, and I'm taking some stuff out, but the embarrassing fact, ... that this is the largest disparity between theory and observation in the entire history of science. And I was like, wow, that's a very strong comment and a very of course, exciting comment in a way. What is dark matter? How does it relate to, well, let's start with what is dark matter? What is dark energy? How are people misusing those terms? I mean, I would love to just hear from a pro, which you are, like how should we think of these things?
Well, it's funny because we've given them these names that make them sound mysterious and exotic and even ominous. So dark matter is matter, which is to say it interacts with gravity like matter. It clumps together like into galaxies, for example. But what makes it dark, and actually I'm going to come back to that name dark, which I think is very misleading, is that it does not interact with light. That is to say, if light hits dark matter, it just passes through. In fact, billions of dark matter particles are passing through us every second, but we just don't know about them because they interact so feebly. They interact gravitationally with us, but so far as we know, they do not interact with light. And this comes back to the word dark, which I think might have been better called transparent matter. Because after all, we see things that are dark. They absorb light. But we don't see dark matter because light just doesn't interact with it. I mean, there's a hope that there's a tiny interaction that will help us find it, but so far we've seen no observational evidence of that. So it really is just matter. And it's interesting. There's about 5 times the amount of energy carried in dark matter as ordinary matter. Most people find it interesting because they say, wow, are you telling me that most of the matter in the universe isn't the stuff we're made of? But I think I have exactly the opposite point of view. I'm amazed that, we're just random. Why should we be as substantial a fraction of the matter in the universe as we are? In fact, why should these two be comparable at all if they're only interacting via gravity? You might have imagined that there was 1 trillion times the amount of dark matter or 1 trillion times less the amount of dark matter, yet the amounts are remarkably comparable. And we actually think that might help us, that might ultimately be a clue as to what dark matter actually is. And by that, just to be clear, it's not quite as embarrassing as everyone is saying. There's actually observational evidence through gravity that this dark matter exists. It does influence things. It does have gravitational effects. It affects the motions of stars. It affects the motions of galaxies themselves.
Or the trajectories of comets or asteroids.
Well, if our theory of dark matter is right, it can also affect the trajectory of comets. And I'm very, very happy to talk about that too. So it's not that we haven't measured dark matter, we've measured it. We just don't know fundamentally what it is. And by that I mean, is it a particle? Does it have a certain mass? Does it have any interactions at all? And coming back to affecting comets, my proposal with my collaborators is that maybe most of the dark matter doesn't have any interesting interactions other than gravity, but maybe a small fraction, say 5%, does interact. And maybe it even has its interactions with its own light. Just like dark matter doesn't see our light, maybe this dark matter has light that we don't see. And if that's true, it too might have formed a disk, just like the Milky Way forms a disk. The ordinary matter forms the Milky Way disk. And maybe the effect of that dark matter's gravitational force is when the solar system comes through it to actually trigger comet strike. And we can talk more about that if you like. Well,
there's so many things I want to talk about. I know we have some time constraints, but there's another, I'm not sure where I picked this up exactly, but it came up in association with your name somehow, and I wanted to ask, since we're getting outside of the Earth and talking about different phenomena, but looking at our galaxy, why are the outer planets in our solar system bigger than those closer to the sun?
Well, so that obviously is going to have to do with the heat of the sun. Mm-hmm. So if you're too close to the sun, things like hydrogen are just going to evaporate. So the inner planets are rocky. They're made of silicon and things like that. But there isn't as much of it, the stuff that the inner planets are made up of. So what there is gets trapped, but that's it. The outer planets are made up of much more abundant materials like hydrogen, and they're frozen. So they're and then this outer region where they're frozen. So we talk about the rocky inner planets and the frozen outer planets, and there's a lot more of that stuff, and so that stuff can grow to a much bigger size.
Got it. So there are a couple of questions I'd love to ask about distortions or misapplications of physics, and I would love to hear kind of what are some common, I would say old wives' tales, but they're not really old wives' tales, misuses of physics that make you cringe. So for instance, whether that's people misunderstanding spooky action at a distance, people say everything has its frequency. There's a lot of kind of woo-woo stuff out there.
Well, the one I'm going to say is I'm going to turn off half your audience.
Perfect.
I can't stand the way people use energy to mean anything they want. Energy is very specific in physics. I mean, there's many different forms of energy, but for example, energy is conserved. So it's not something you just talk about the energy of an object or the energy is passing through or the energy trope, or I have good energy or bad energy. It's in physics. It really has a definite meaning. It can be converted to mass. It can be converted to other forms of energy, but it really means something very specific. And in common usage, energy is used all over the place for whatever anyone wants it to mean.
So in physics, what would the definition look like then of energy?
I actually don't know that I have a great definition. It's a conserved quantity.
Okay.
So if you have a certain energy, it will stay the same.
No, it sounds like a tricky one. It's kind of like IQ is that which is measured by an IQ test.
Yeah, that wasn't a great definition, I will grant you. I mean, I can give the problem is the definitions I would come up with are too technical.
Oh, yeah.
So I'm trying to think of one that I can give to your satisfaction.
No,
and I don't have one off the top of my head.
Yeah, we can come back to it. That's not a big deal. So energy. Anything else come to mind that just drives you nuts?
Well, it's a little bit unfair to say this drives me nuts, but there are some questions that come up again and again, like if the universe is expanding, what is it expanding into? The answer is it's not expanding into anything. The universe is all there is. Stuff is just getting bigger. So you can use an analogy. If you were willing to assume a balloon was all there is, I realize a balloon is blowing up in a room, but imagine the balloon is all there is, and just draw points on the surface of the balloon. When you blow up that balloon, those points will get further apart. Mm-hmm. So even though the balloon is all there is, it's getting bigger. And that's the way the universe gets bigger. Mm-hmm. It's all there is, but it is getting bigger. Mm-hmm. Another misconception is that, that dark matter doesn't make sense. But I think dark matter is probably one of the most simple modifications of the physics we know. It's just saying that there's some matter that doesn't interact with light. And why should all matter interact with light? I mean, after all, the matter we know of is made up of atoms, and which do interact with light, or is at least made up of stuff that's charged, namely protons and electrons. But why should all matter be made up of protons and electrons? Why can't there be other types of matter that don't interact with light? So that's another one. And I think there's also just this level at which, it's almost, people almost will sometimes prefer the romantic notion than understanding. One of the things I do in my books is I'm just trying not to make it seem exotic and not to make it seem overly mystical. Just to say, this is what we mean by this, and it's not necessarily as confusing as you say. So I don't use the word spooky. I don't use the words magical. I just say what it is and what it means functionally.
Mm-hmm. Well, I also, it makes me recall a conversation that I believe it was in one of Richard Feynman's either lectures, or I think it might have been in The Joy of Finding Things Out, which was done by Nova. Fantastic interview with him, a profile of him. And he talked about a debate with an artist friend of his who said that since Feynman was able to break down this flower into its physical components down to the atomic and subatomic levels, that it lost the beauty, that he couldn't appreciate the true beauty. And he argued exactly the opposite, that it sort of provided a framework through which he could better appreciate the flower, in fact.
So I would actually argue that it's neither. And in fact, in Knocking on Heaven's Door, back to this notion of affective theory, it's sort of different ways of looking at it. So I actually talked about music. And I talk about music as you can understand it as oscillations of air in your ears, which get processed by your brain. And then you can understand what music is at a totally different level. And I would say that's sort of affective theory. You're using different ways of describing it, different parameters. You won't even use the same words necessarily because you're talking about it at a different level. Yes, fundamentally, for there to be music, I need air, I need those oscillations, I need to be able to process it in my brain. But I don't think that comes anywhere near describing what music is. And I think no one is actually going to be able to describe what music is. I mean, you can functionally say what it is, but what it means to me as a person is going to be described at a totally different level. And that doesn't negate the physics interpretation. It's just that I don't think it fully qualifies as explaining it either.
Mm-hmm. That makes sense.
Excellent.
This is going to be a bit of a shift of gears, but and this may be right alongside what is the universe expanding into, a question that bugs you, but I'm going to risk it. Is the flow of time?
You're allowed to ask questions that bug me.
Okay.
I'm just telling you they bug me.
I probably specialize in them, but is the flow of time an illusion?
I actually think the flow of time is very real, and it might even be the way we define what time is. I mean, it's funny, when I wrote my first book, I realized I was able to come up with, some of them are difficult and complex, but I was able to come up with an intuitive explanation of almost all the concepts. The whole goal is to describe it without math. But time is really difficult to fundamentally explain. What is the difference between time and space? I mean, in technical terms, in the space-time metric that you do measurements, there's a different sign. But that doesn't tell you anything intuitively about what it is. And I think time, I would venture to say that we don't fully understand yet what time is. But in some sense, one thing time definitely seems to be is something we measure as things evolve, as things change, as it passes. So I would say that it's almost essential to describe what you said in the beginning. I don't remember the exact words you used.
Mm-hmm. Are there any?
If that question bugs me, it only bugs me because we don't understand time any better than we do.
Are there any particular physicists or scientists researching time, or who have kind of unique perspectives on time?
I'd almost say they're more philosophers because there's no science kind in the sense that you're not doing predictable theories. I mean, you can come up with ideas of time going backwards or forwards or how it works. But I think there is a meaning. I'd say the most interesting things have to do with probably the idea of, there was something called, it is connected to cosmology and what defines the universe going forward, and maybe cosmological inflation in the beginning. There were things that happened as over time very quickly. Something called entropy increased a lot, which is sort of how many degrees of freedom there are.
Right.
So I think there is interesting work trying to understand what an inflationary universe really means, how it really started. But again, it borders on philosophy.
Is there? So philosophy has always been, it's sort of a contentious subject for a lot of people, but now you have artificial intelligence and sort of utilitarian philosophers being brought in to help people to write code. So let's say an autonomous vehicle has to choose between hitting 2 school children or 5 grandmas. Which does it choose, et cetera? I mean, some of these thought exercises previously limited to like freshman philosophy seminars are suddenly becoming relevant. Are there aspects of philosophy that are becoming more relevant to physics, or is that not the case?
That's an interesting question. Sometimes philosophy helps just framing what might be an interesting question, but then physics is going to go ahead doing it the way it does it. There are some interesting discussions, like I said, on kind of topics that we don't fully understand. So it's really in the regime where, you can question whether we're really making progress in physics. I think in the realm of moral philosophy, I think that's probably one of the areas where philosophy is, I don't know if I'd say advanced, but I think it's a really interesting area because there are interesting moral questions that we do have to address. In a lot of the rapid changes that are happening today. In terms of philosophy and physics, one of the chapters in my new book, Dark Matter and the Dinosaurs, when I talk about cosmology, I first have a chapter on the big questions. And I sort of define as philosophy the questions that everyone wants to know the answer to, but that we don't really have definite answers to. It doesn't mean people can't think about them, but it's questions that we might not have satisfactorily resolved. Questions like, what was there before the Big Bang? Or, what was the Big Bang? So there are a lot of questions, why do we have something rather than nothing? Although I do have a tentative answer to that one.
Oh, okay. Well, let's come back to that. Yeah. Or we can do it right now. I mean, why something rather than nothing? That's a big one.
Well, my answer is, first of all, you can't ask the question unless there was something. But also, in my mind at least, nothing is a very unlikely possibility. If you think about it, a zero on a number line is very, very unlikely. And if there is if you do happen to get it, there's usually a reason for it. And that also means there's something. So it's just very hard to imagine nothing, at least for me, as being the most likely outcome. It seems something is much more likely. I joke that, you don't always find what you're looking for, but you usually find something.
Yeah, it brings up all sorts. I mean, I won't take us off the rails, but I think
that's what happens when you start discussing philosophy and physics. You go off the rails.
No, it's great. This I think we'll do a round 2 with more wine. I was chatting with a mutual friend of ours, and she said that you and she have discussed the idea of how science can expand empathy and our ability to see beyond ourselves. And I don't want to put words in your mouth, but if that's the case, could you elaborate?
Well, it's something I discuss. I use a lot of analogies in the book actually related to that. When I talk about dark matter, I talk about other things. And actually, for those who are interested, I have an op-ed coming out in the Boston Globe about this. And the idea is that it's a difficult concept to explain, so bear with me. Let me try to say it in words. It's easier to write almost. But, when we do physics, when people, it's sort of almost a reaction when I talk about particle physics and things that are removed from our everyday experience. I taught a freshman seminar where even the students recognize things that are removed from our everyday experience, we tend to think of as less real or less important. So if I talk about a quark or the Higgs boson, your reaction is, that's kind of interesting, but who cares at some level? Mm-hmm. Because it's not what we're encountering our daily life. But if you're at the scale of a quark or a Higgs boson, that's really important. And, we're made of ordinary matter, so we tend to think of dark matter as not that important. But there's 5 times as much of it. And furthermore, it gave rise to the development of it helped develop galaxies. So it's really relevant to the universe. And, we do the same thing in sort of social classes, that we can forget the masses who are building buildings. We'll remember the leaders or the architects, but we forget the people who led to the construction. We'll look at our society, but we'll think of other societies as lesser in some way because they're not ours. And if you're in another society, then you think yours is primary. So I think you have to get outside that perspective. And I think in science, we all know that we have to get outside that perspective. We're never going to understand things, or the scale of the universe for that matter. We have to allow ourselves to think of it. And I think the same thing applies to sort of social interactions as well, that you really have to imagine a different perspective to fully understand it.
Well, I think that it seems...
Does that make sense?
It does. No, it does make sense. It seems to me that being a scientist, fundamentally, among other things, or putting it a different way, using the scientific method or thinking scientifically involves, among other things, forming hypotheses and recognizing their hypotheses, testing those hypotheses, but also being aware of and or testing your assumptions, right? So I think that, and the kind of meta skill, I suppose, on top of all of that, or one of them is being observant and noticing the kind of invisible, or trying to notice the minute.
Absolutely.
So I agree.
Noticing the little places where things don't quite fit together, and taking them seriously. That's absolutely right.
What is the difference?
And also,
yeah, I'm sorry. Go ahead.
I was going to say, and also sometimes it's, having a fresh perspective. I mean, when we found the existence of an extra dimension of space was possible, we were coming at it from particle physics. We weren't people who do primarily general relativity. In fact, we were told that that's impossible because there were theorems saying it was wrong. But because we had come at it from a different direction, we sort of essentially accidentally discovered a solution that we can then go back and see where the fundamental assumption was wrong, like what had been missed. Mm-hmm. And, the work we're doing on dark matter now, this idea that there could be a dark matter disk and it could affect astronomy, that came because we were trying to understand some observation that could have been a dark matter detection. We were sort of coming at it from a different direction. We weren't astronomers. And so sometimes it helps to have come at it from different perspectives, but to be open to what the people in the field say, of course, but to really take as valid all these different points of view.
I have to ask you about Interstellar. I can't forget. What did you think of Interstellar?
I thought it was an interesting experiment. The idea was science that was possible, not necessarily likely, but never to have anything that that we knew couldn't happen. And I think that was admirable. I also think it was really admirable to have the characters take science so seriously, to try to talk science. I mean, I'm not saying I loved all the dialogue, but I think it was really interesting one of the things I felt was interesting, though, was to treat science as if it's just part of everyday vocabulary.
Right.
And that I really liked, that it wasn't taken as some other thing. It was just part of their daily lives. Mm-hmm. So I think there were some really interesting ideas that were explored in that movie. I had heard so many sort of criticisms of the movie, and I didn't dig into the details, and I really enjoyed it. So that's that. I'm not sure why I felt it necessary to proclaim that, but here's a kind of a wacky question, maybe, and I'll start with just an observation, and an observation is that if I talk to neuroscientists, particularly people who are not, say, behavioral or cognitive focused, but those who are really focused on sort of neuroanatomy and look at lesions and the effects of lesions and so on, they tend not to believe in the afterlife. I've had the opposite experience with physicists, or something after, sort of consciousness after physical death. I know this is getting out there, but am I totally off base there? I mean, if you look, I think you're talking to a very unrepresentative physicist.
Okay.
Right. There are some who are religious, but I think, part of what physics says is how things are tied up to their physical makeup. I mean, that is essential. Right. Mm-hmm. It doesn't mean we understand it. It doesn't mean we understand how everything fits together to give you consciousness, or whatever it is that constitutes a person. But that physical stuff is really important. And, I should say, I've been in tricky situations where, I'll really feel for people because, working on an extra dimension of space or talking about physics, people really want to believe these things, or, it'll be heartbreaking. Someone will say, my sister died really young. I think she's in an extra dimension. But, I'm very sympathetic to their desire to believe it and to want to believe these things persist. They certainly persist in our memories, but I personally think that things are tied to the physical reality. Doesn't mean I overestimate my understanding of it. I don't know that connection. I don't know how it works. Mm-hmm. But I do think that a fundamental physical reality is essential. And if you have a question about that, here's one question I have, which is sort of, how as a scientist you might approach a problem. My mother passed away a couple of years ago, and she really did injure her brain. And so she became a very different person. So, where is the person in that? If you really want to believe that there's an afterlife, what happened to the person in that state where they're still alive, but they've really hurt themselves?
Right.
I mean, it's a horrible reality to face, and it was a horrible thing to watch. But I think that's the kind of question. If you really want to believe that, you have to be able to answer those questions.
Absolutely. Yeah, it's a very tough question. I mean, this is, I've had Sam Harris on the podcast before, and he brings this up in I'm sure he's written about it, but he's also brought it up in discussions on this very topic. He has no shortage of debates with religious folks, as you might imagine.
Yes.
So let me ask a question.
But my goal in having these debates is that people actually listen to each other so they can actually come to some resolution.
Right.
But go on.
Right. No, understood. So I have a question from a reader. This is from Mary Grace. And if this question is too time consuming to answer, then you can pass. But here's her comment. I studied pure math in college, and one of our favorite things to do was debate with the theoretical physicists on whose major was crazier. Of course, we each thought the others was crazier. I'd like to hear her description of an object, example, a tennis ball, as it moves through additional dimensions of space.
Well, first of all, you have to explain to me what that tennis ball is made of. Because the tennis balls that I know are made of students that I know live in 3 dimensions. Mm-hmm. So could it be that, so one of the things I talk about in War Passages is the idea of what's called a brane, B-R-A-N-E.
I'm sorry, say that again?
A brane, B-R-A-N-E, mm-hmm. which is, could be a 3-dimensional surface in higher dimensional space. So maybe it's as boring as the ball just stays in the 3 dimensions of the brain. If the ball wants to get off the brain, it has to be made of something that can exist in those other dimensions. But we have very serious observational constraints of what the extra dimensions can look like. So I think so I'm going to take the cop-out solution answer right now, which is not crazy at all, and just say if there is an extra dimension, the tennis ball might not be going there. So.
Got it. Okay, let's talk about what is the significance the significance of the Higgs boson?
So I actually wrote I wrote an ebook called Higgs Discovery of Empty Space, where I try to discuss it because I have to say, when I wrote my first book, like the Higgs boson is probably one of the hardest things to explain. But let me just give you a couple of answers. First of all, the Higgs boson is experimental evidence that our theory of how particles acquire their mass is correct. So the actual way particles get their mass is not from the Higgs boson itself, which is a particle, but from something called the Higgs mechanism, which involves something called the Higgs field. So these are all different, so it's a little confusing. But the idea is, in some sense, to try to give just a sense of what it's saying, is that throughout space there's like a Higgs charge. Not actual particles, but like a charge. And particles that get mass through the Higgs mechanism essentially interact with that charge. So and ones that are heavier interact more, ones that are lighter interact less. The Higgs boson is connected to that field that's spread throughout space. So the Higgs boson interacts with heavier particles more, and with lighter particles less. And so it does 2 things for us as scientists. It tells us, first of all, the idea of the Higgs mechanism is in fact correct. And it also gives us some idea of what it was that produced that charge in the first place. It tells us about something called the Higgs field, which is what's spread throughout space. So the discovery of the Higgs boson really tells us how elementary particles, and by elementary particles I mean things like quarks and electrons, how they get their mass. They don't just have mass from the get-go. If they did, the theory would make totally nonsensical predictions, like probabilities of interactions at high energies being greater than 1. It really requires some sort of mechanism, and that mechanism is the Higgs mechanism, having to do with essentially this charge spread throughout space. And if that seems really confusing, it's because it is. It's hard to understand without really going through all the math of it. But that's essentially the essence of what's going on.
Mm-hmm. And now that has been verified, what's the biggest thing, the sort of the number one that physicists are looking to verify?
Well, physicist is a broad term.
Yeah, I don't know how to slice
particle
it.
Physicists,
there we go.
Particle physicists, those people who really study what's happening in the Large Hadron Collider, are looking forward to understanding 2 things, if we're lucky. One is connected to the question of why is the Higgs mass what it is. Without something else around, we would actually expect it to be like 16 orders of magnitude heavier, like ridiculously heavy. But we know that's not the case. And we know what the Higgs boson mass is. So the question is, what else is there? And so it turns out the answer to that question involves some very exotic ideas, like extra symmetries of space, or this idea of an extra dimension of space that I talked about. The other thing that people hope we might get some insight into has to do with dark matter. It could be that a dark matter particle can be produced at the Large Hadron Collider if one of these ideas about what's going on with the Higgs mass is correct. We don't know that's the case, but searchers are going on to see whether we can produce dark matter at the Large Hadron Collider as well.
Mm-hmm. I have another question from a fan. This is from Peter Shaw, and I'm going to slightly adapt this and paraphrase it, but his question, I think, is, and you may have partially
answered. Have you been waiting for this all your life to just get a physicist on the line and just ask any question you want?
I am fascinated by physicists in inverse proportion to how much I know about it. So it's like I know so little about physics. But I'm endlessly fascinated by it because I admire some of the precision, and I also admire the willingness to deal with messy problems.
And the great thing is, if you know more physics, it actually stays interesting.
Yeah, so I'm trying to make up for lost time. But
Back to the Future.
Yeah, during my summer program when I was supposed to be studying physics, I fell in love with this Turkish girl, and that was kind of the end of my physics. But the question from Peter Shaw, sorry, I was lost in reverie for a second, is why does research into cosmology matter? Theoretical physicists are brilliant, but most modern ones seem to be interested in the cosmos. To the layman, he can't see the direct benefit of this research.
So here's the question I have for your fan. Does matter? I mean, I think nothing matters more than sort of understanding what's going on, what the universe is made of, how we got here. Yes, we can maybe find ways to cure disease and live another day. We can find perhaps new sources of energy and be able to power our gadgets more. But, and that's all fun, and it's certainly enjoyable, and we think of that as a purpose. But there's another purpose, which is just to really learn things, understand things, value things, have culture, be human beings. And so I know that for many people that might not be the most satisfactory answer. And to those people, I can remind you that most basic science, we didn't know what the implications or applications would be at the time. And that doesn't just apply to physics. I mean, I can guarantee that Watson and Crick were not trying to solve cancer when they were exploring DNA.
Right. That's a great example.
The fact is,
that's a great
basic
example.
research matters, and it comes down to help us. And it also gets people excited about science. It gets people, I don't think it's coincidence that places that have great science also have good economies, good healthcare. There's correlations, and it's because people who value these things are valuing what's important.
And so our mutual friend also brought up, and I wanted your help defining these terms, that sometimes you're frustrated about getting people to value basic science versus kind of the sexiness of applied science. Could you just define those two? I mean, I could take a stab at it, but it would be sloppy. What is the difference between basic science and applied science?
Well, so basic science is, trying to understand DNA without trying to understand, can it be useful? I mean, what will it do for me tomorrow? Applied science is more saying, I want to solve a disease. I want to build a computer. Quantum mechanics helped with the development, ultimately gave rise to the electronics revolution in some sense through semiconductors. But I can assure you, people working on quantum mechanics were not thinking about an iPad. They were thinking about trying to understand how the atom could make sense, or how radiation could make sense. And so it's really, basic science is just trying to understand how to make sense of what the world is made of, how to make sense of how things work. Applied science is trying to answer the question of your listener or reader. Can you use this to make my life better tomorrow?
Mm-hmm. Well, it's in an odd way. I do a lot in the tech world. There are comparable differences among entrepreneurs or tech builders. You have people who try to determine a market or a market size, a total addressable market, blah, 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 and then build for that, which would be, I suppose, the equivalent of applied science. And then you have the person who's just scratching their own itch. And that may be for a particular need or want, but it could also just be out of curiosity. And the most impressive.
And isn't curiosity a great thing? I mean, it's just what makes the world worth being in. Just being curious. It's so great.
Totally agree. Yeah, totally agree. All right, so let's completely switch gears if you don't mind, and I would love to ask you a number of questions that I love to ask. The first is, when you think of the word successful, who is the first person who comes to mind and why?
You asked me that. It's a really tough question. I don't know. I really don't know the answer, but I think there are people out there who are just very happy with what they're doing, and with or that feel like they've done something. But even it's hard because the successful people I know always are looking for more. So I don't. It's just I'm sorry. I just don't have one name that comes to mind.
Okay. Well, let me take a different angle.
I think you're successful. How's that? I think you're successful.
Oh no! If you only knew. But
see, that's my point.
No.
Everyone who's successful, if you say it about them, they'll think of all the things they didn't do. But in many ways, you're very successessel.
I should say the same of you on a much larger scale, with much bigger questions. But in the last 5 years, when have you felt the most successful?
Oh, that's interesting. The last one, I do think that when you have, even those little things where things tend to click, where you have some idea that is going somewhere. I mean, when we developed this idea of double disk dark matter, it was very exciting. I don't know that I would consider it a success, but it was very satisfying.
Which was this? I'm sorry?
I'm sorry. The idea of this dark matter that we're looking at that does have these interactions, that can form a disk inside the Milky Way, that could be denser. It was really, really interesting to put that all together.
Right.
And to realize this really did make sense and was something that was relatively unexplored. It was really exciting. When I'm writing a book, I feel successful when I get the idea to match. You sort of have a vision of what you want to be saying. You have a vision of how you want to fit together and get some rather complicated ideas across. And so when I've done that to my satisfaction in a way that I find readable and enjoyable, I feel like that's a success also. When I'm doing a rock climb and I do this climb that I thought was going to be too hard, I feel successful. It's sort of these little achievements that make me feel happy.
And I wish we had more time to dig into the rock climbing, but we'll have to save that for a follow-up. As a side note, there's an interview I just did with a guy named Jimmy Chin, and there's a documentary he's featured in called Meru. If you're into climbing, you should definitely check out Meru. It's incredible.
Great.
Yeah. It's about this particular climb that has defeated the top climbers for about 30 years. It's fantastic. But the next question is about books. What is the book that you've given most as a gift?
Well, I mean, the embarrassing fact is probably it's my books because those are books that people like getting.
Right. Excluding your own books.
Aside from that, the sort of books that I'll give to sort of young girls, like I really love the book I Capture the Castle.
Capture the Castle?
I Capture the Castle, which probably sounds like an odd choice for someone who's a physicist, but I just think it's a really lovely book about the importance of art and just understand the world and being surrounded by crazy people. It's sort of a young adult book by Jody Smith, but it's just a lovely book, and so probably I've given that too.
And it's called I Capture, present tense, the Castle.
I Capture the Castle, yeah.
Awesome. I'll check that out. I'm the kind of guy who reads...
It's a girl's book in some ways, but it's really a lovely book.
Yeah, it bugs me that books, and I only figured this out recently, are slotted into young adult, not because the books are necessarily intended for young adults, but because the main characters are young adults. I had no idea. It's like the gold.
That's interesting. I didn't realize that's always
like the Golden Compass was slotted into young adult, and I had to look up probably 300 words in that book to just figure out the definitions. But I'm digressing. So I Capture the Castle. Do you have? It's not the right way to start this question. What are your favorite documentaries or movies that come to mind?
I don't want to answer that because I never. So I guess
Let me guess. Let me guess. You don't want to answer it, so I'm going to say Kickboxer 2. Is that it?
I'm actually forgetting the name, but there was one about the downfall of Wall Street that was really great.
Oh, the downfall of Wall Street. Is it Too Big to Fail? Is that what you're talking about? The documentary with Matt Damon?
No, that wasn't that one. It was an actual documentary without actors in it, and I'll remember the name eventually. I'll get back to you on it.
We can come back to that.
Sorry.
So here's one about purchases. What $100 or less purchase has most positively impacted your life in the last 6 months, a year? It doesn't really matter.
Well, I'm going to give you two that are very different. One is probably like new climbing shoes. But another is actually I bought.
What was the first one? Sorry?
New climbing shoes.
What are they? What kind of climbing shoes?
They're just Mythos. It's just that it was just really nice to get better soles on my shoes so that I could climb better again. The other is probably like, this sounds really silly, but I got a Human Touch dish rack, and it just looks so clean and efficient that it encourages me to be neater in my kitchen. And
Human Touch.
Yeah, it's just a really nice dish. I mean, it looks a little bit space agey, but I just like the organization of it. It just makes me feel happy when I look at it.
No, that's perfect. That's exactly the kind of thing I'm looking for. What is something you believe that other people think is insane, if anything?
Well, I don't know if people think it's insane, but like my answer to why there's something rather than nothing is probably a little bit unconventional. Mm-hmm. So that's probably the closest we can come to that.
Got it. Here is what. Okay, so the first question is, what is superstring theory?
Oh, wait, I guess the other thing, I'll add something to that. I think the other thing I believe, I don't know if people think it's insane, but I really like to believe that when people know more, they will make more sensible decisions. And that probably is insane because we don't always have evidence of that. But sometimes, especially when trying to explain the kind of science I do, people will be like, why are you doing it? I do think that once people understand things, they will value them more. Mm-hmm. At a very fundamental level, this isn't about knowledge so much, but, when I first saw the big redwood forest, I understood, this is why they want to preserve the forest. You can read about the spotted owl all you want, but it's like when you actually go and experience it. But also, when you see politics today, I feel like if people really actually had access to the actual information and not just present with one side, but really can get it. And that probably is insane because there's a lot of evidence that's not true. But I still would like to believe that people, it's sort of what drives me to sort of do these things where you're writing books or talking about things. Is that when people know more, they will do better things.
Mm-hmm. Yeah, I tend to agree. Here's a question from a scientist friend of mine. Lots of interesting work has been done in large programs like string theory and loop quantum gravity that don't yet connect well to the observable universe near current energy limits. What do we need to do to get more mavericks trying different things?
I'm not sure I understand the connection between the two parts of the question.
Well, so his first part was ask about the great slowdown in particle theory after the standard model got finished around 1973-74. Specifically, why has so much energy been spent on large programs that have yet to deliver rather than funding individuals who want to try new things? So that's...
Okay, now I understand better. My reaction to that is to try to work on things where you can make progress. I mean, that's why before I worked on particle physics with but now, I still work on particle physics, but I'm working on dark matter because I think both theoretically and observationally in ways that I talk a lot about in my book, I think it's really poised to make progress. I think there's a lot going on that can teach us about it. And one of the roles as what I call myself as a model builder, one of the roles I have is just new ways to look for new phenomena so we don't miss things with the observations that we do. I think, the fact of the matter, though, in answer to your question, is that scientists are people just like everyone else. Everyone likes to see other people doing what they're doing, and they think what they're doing is the most important. So I think just people have to be more open-minded. I mean, one of the amazing things of, you ask why did Einstein become known? It's because Planck really read his work and realized it was important. Another physicist who was established read it and it was important. And I think we just have to really listen to good ideas when we hear them. And, that takes time and effort, but it's important.
What are common if you want to answer this, I don't even know if they exist, but what are the most common misconceptions about you or about your field? You could take it either way.
I think people think I'm scary.
Scary?
And I don't really get that, but I can tell sometimes people think I'm scary.
Why do people think you're scary?
I think it's because anything that's out of the norm is sort of initially scary. It's not like everyone thinks I'm scary, but I think, you hear that there's this woman physicist that whatever. I mean, people assume that there's sort of some foreign being or something. So I think maybe that there's a little bit of that. I'm probably exaggerating grossly, but I do know that, people will misunderstand who I am a lot. I think also I have this annoying feature of being very direct. And I think, like I said, I wasn't properly socialized, so I didn't learn all the proper circumlocutions.
The niceties of society.
Yeah. I just don't like wasting time. So it's like, can't we just say what we mean here? It's like, I think also, another thing is I can actually argue a point without, I can disagree with a person and still like them. It doesn't reflect on what I'm thinking about the person, the fact that I might disagree with their point of view. And I think that's also something very foreign to a lot of people. People take it personally if you have an argument, and I don't mean it personally.
Mm-hmm. What is superstring theory?
It's really out there. But, I talked about particle physics before. So string theorists think that the fundamental nature of matter is not just elementary particles, but it's actually fundamental strings, which oscillate to produce the different particles. But that fundamentally it's strings and not particles. But that really would be a whole other hour.
Okay, all right. Let me, just because somebody I care a lot about wanted me to ask, because he's genuinely interested, is if superstring theory is not falsifiable, does that mean it's not worth pursuing? Or
so, that's a tricky question. I would say the answer to that is no, which is a double negative there. So, I don't think everyone should work on it, but I do think there are ideas that come out of string theory, even if it itself isn't necessarily being tested. So, it can be applied to other types of problems. Some of the work that I did on extra dimensions of space came about because I was thinking about ideas from string theory, and some of the implications of our ideas reflect on what can happen in string theory. String theory is also used to understand black holes, for example, and eventually there will be experimental tests of that. So you might not test the entire theory, but you can test pieces of it or use it to come up with methods. It's also been used for math. I'm not saying it's the only thing we should do, and I myself don't consider myself a string theorist, although I will do stuff that interfaces with it. I prefer to do things that are more directly connected to experiment. So I would say that, just like everything else, in America we tend to sort of go in extremes and think everyone has to do something, or everyone. I think there's a place for it. It shouldn't be everyone doing it, but there's a place for it.
If you could have one billboard anywhere with anything on it, what would it say?
Be curious and try to find solutions to problems.
Be curious. Do you think you can train curiosity? If for a school curriculum, is there a way that we could better instill or foster creativity in some, or curiosity, excuse me, in some way?
Well, that is a good question. And I think a lot of it has to do with, when people ask questions, taking the question seriously. That can be tedious, and it's not not every question is a good question. But sometimes, people will ask questions and they'll get cut off or they'll be ignored, and it tends to make you not want to ask questions. So I think, basically, people have to listen to each other. And if people listen to each other, I think they'll get more curious. And also be given opportunities to explore, opportunities to read, opportunities to work on problems. I think people are naturally curious. So the question is not to get rid of the curiosity.
Right. How do we avoid neutering that curiosity? Perhaps.
Right.
Just a few more questions. What advice would you give to your 30-year-old self?
It sounds kind of funny, but I probably would say don't take yourself quite so seriously.
And if you don't mind placing for us that in context, what were you doing at 30, or where were you?
Let me think. So at 30, I was a professor at MIT.
Got it. And when you were a PhD student, what advice would you have given yourself?
not to take myself quite so seriously.
Got it. Well, this has been so much fun. I have
thank you.
one last, and then I'm going to point people off to...
Is that a lead into a question I don't want to answer?
No, not at all. And last but not least, just out of curiosity, no, do you have any ask, aside from checking out the book and everything you do online, which we'll do in a second, do you have any ask or request for my audience?
That's a good question. I think, I'd like to know, sort of which explanations that I've given, in my book or even on here, people find helpful.
Great. They can do that. Where can they let you know?
I have a Twitter account. My handle is actually not Lisa, but Lyra Randall, LIRARANDALL. But also, in my book, I'd like to know if the points come across, if people understand what I'm trying to explain. And also, these various analogies, like, do they get that they're working at two different levels?
And where can people find you online in the book besides on Twitter? Where else can people find it?
Well, the book is on Amazon, like all other books. I have a Harvard account and I'm actually in the process of setting up a web account for the book, but the only social media thing I do is Twitter right now. And other than that, there will be a website soon. So just look for Lisa Randall or Dark Matter and the Dinosaurs website. One of them will happen soon.
Wonderful. And guys, the book is Dark Matter and the Dinosaurs, subtitled The Astounding Interconnectedness of the Universe. It is currently #1, and it's in paleontology, of all things.
I love that.
which is great.
It's not out yet. It's all pre-orders now. It comes out next week.
Yeah. Or when you're listening to this, it might have been out for a year or two. So
I'm sorry.
check it out.
That's
That's okay. That's all right.
Future.
We did give that's all part of our Back to the Future theme. And
Exactly.
check it out, guys. I have personally made a commitment to get back into reading more of physics, and I would say, if you want to try psychedelics but aren't going to actually do it, if you want to put on a new lens through which to view everyday life, so-called ordinary life, but gain an additional perspective, this is a great way to do it. So,
what a lovely thing to say. Thank you.
of course, yeah, my pleasure entirely. I love this stuff, and I need to resolve to actually learn something about it. develop some fundamentals.
No more Turkish girls.
I know, got to avoid the Turkish girls. Very distracting. But I really appreciate the time. And is there anything else you would like to share before we end this round one?
Well, I think there was quite a lot to share, but I actually really find it rewarding. You spend all this time, I do research, but you spend all this time writing the book. So it is so rewarding to me when people really are interested and really do want to understand these things. And that's what I'm writing for. So thank you.
Yeah. To me, I mean, these are some fundamental and basic aspects of reality that you and other physicists are digging into. And like you said, Watson and Crick were not trying to solve cancer. And I think it's easy to kind of miss the longer term implications of a lot of what's being done in basic science. So I'm really happy to have you on. And everyone listening, you can find the links to things we've discussed, favorite books, I Capture the Castle, etc., and everything else we've talked about, including the book, at 4hourworkweek.com/podcast. You can also just go to 4hourworkweek.com, all spelled out, click podcasts for the show notes for this episode and every other episode. And Professor Randall, thank you so much for taking the time.
Thank you so much for doing this. It's been really fun.
And everyone listening, until next time, thank you for listening. Hey guys, this is Tim again. Just a few more things before you take off. Number one, this is 5 Bullet Friday. Do you want to get a short email from me? Would you enjoy getting a short email from me every Friday that provides a little morsel of fun before the weekend? And 5 Bullet Friday is a very short email where I share the coolest things I've found or that I've been pondering over the week. That could include favorite new albums that I've discovered. It could include gizmos and gadgets and all sorts of weird shit that I've somehow dug up in the world of the esoteric as I do. to. It could include favorite articles that I've read and that I've shared with my close friends, for instance. And it's very short. It's just a little tiny bite of goodness before you head off for the weekend. So if you want to receive that, check it out. Just go to 4hourworkweek.com. That's 4hourworkweek.com, all spelled out, and just drop in your email, and you will get the very next one. And if you sign up, I hope you enjoy it.